All right, guys, we're going to look at a little bit of today's homework. In the first page, we're looking for things that we would have to be given to prove some triangles congruent, and it's asking us to prove them congruent in certain ways. So if we look at the first set, we're trying to prove by side, side, side. I want to take a look at the one here in the middle. First of all, remember that there are three things that we can look for in our proofs. We can always look for vertical angles, we can look for reflexive pieces, and we can look for parallel lines that will lead us to some congruent angles. So when I look at this quadrilateral here in the middle, I know that I can go ahead and mark that VT is congruent to itself. That is our reflexive property. We don't have to be given that, but if I want to prove these by side, side, side congruence, what I would have to have is SV congruent to TU. So we're looking for things like this. Now, the one down here at the end, again, I could mark these congruent in the middle for our reflexive property. And then from there, if I want to prove this by side, 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 I would need these two other sides. I would need NS congruent to RS. Now, we could be given this in a couple of different ways. You could be given that S is the midpoint of NR. You could be given that SQ bisects NR. Either way, that's the missing piece of the puzzle. So you're going to do that through the first page. Now, on the second page, we're going to get into determining whether our triangles are congruent. So again, we're looking for reflexive pieces, we're looking for vertical angles, we are looking for parallel lines that we could mark angles congruent. These are what I refer to as the legal things that we can mark in a picture. So when I look at A, I know that I can legally mark my reflexive piece down the middle, and you'll notice that we have three things. We have side, angle, and a side, and the angle is wedged between the two sets of sides. So my congruence here would be side, angle, side congruence. And if we name the triangle on the left ABD, then the triangle on the right has to be named CBD. Remember, we have to match up those corresponding parts. Now, let's look down here at G. Again, I can mark a reflexive piece down the middle. And I notice that I have a side and a right angle. Now, whenever I look at these, I know that side, side angle is not a thing, right? Because it's no donkeys. But if we look at this from the perspective of having a right triangle, not only do I have a right angle, but I have the hypotenuses out here on the edge, and this reflexive piece are the legs. So this is hypotenuse leg congruence. If I name the one on the left KLP, then the one on the right has to be MLP. Look for those legal things that I can mark in an image. So if I look at something like L on the next page, I'm given that SQ and PR bisect each other. So that tells me that PT and TR are congruent to each other, and ST and TQ are congruent to each other. Now, I can only mark that because it's given to us. The only other legal thing that I can mark are my vertical angles. And when I do that, I have two sets of sides and the angle wedged in between them. So I have side, angle, side congruence. Now we have to be careful here because this bow tie is one of those that flip-flops. So on the top, if I have RST, I'm going to have to start out with P on the bottom triangle, QT. Now, there will be some that are not possible as far as this section A through L is concerned. So if you get something that's only angles or that angle, side, 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 side angle, those will just be a no and you'll move on. Let's look at a couple of proofs. So up here on D, I want to start on this one. We always want to mark things in our given. So I'm going to go ahead and mark angle K is congruent to angle N, and angle KML is congruent to angle NML. We also want to mark it in our picture. So step 1 is our given. Mark it in the picture. Angle K is congruent to angle N, and KML is this angle here in the middle, congruent to NML. Here's where we want to look at those legal things that we can mark. We do not have vertical angles, but we do have this reflexive side right here in the middle. So I can mark that congruent to itself, and whenever we mark that congruent, we have to write it in our proof. LM is congruent to LM. That's my reflexive property of congruence. And then from there, I have everything marked that I need. So when we name our triangles, we have KML is congruent to triangle NML, and that will be our angle side congruence. Remember that whenever we are marking them, I've got two angles here, and because the side is out by itself, that's what makes it angle side. Let's do a couple more. Let's look down here at F. Notice that we have some right angles, so we're going to have to try and decide how we want to use our right angles. So in my given, I have that JM is congruent to LM. And I have some right angles. So angle J and angle L are right angles. We could also consider that part of our given, so I'm just going to leave that as number 1 also. All right, now in our next step, we're looking for those legal pieces that we can mark. I'm already given that JM and LM are congruent. What I do notice is that I have this reflexive piece down the middle right here on KM. So I can mark that congruent to itself, and I also have to put it into my statements. So KM is congruent to KM. That is our reflexive property of congruence. Now, when I look at my triangles, I have the blue line here is the hypotenuse set, and these guys are the legs. So remember, if I want to use hypotenuse leg, I have to say that I have right triangles. So I'm going to say on step 3, triangle JKM and triangle LKM are right triangles, and that's just our definition of a right triangle. And now that I have all 3 things marked, remember we always need 3 things in a proof. I need, in this case, the hypotenuses marked congruent and legs marked congruent, and that I have right triangles. Now I can use HL. Triangle JKM is congruent to triangle LKM, hypotenuse leg congruence.